I'll try some. No. All right. Yeah.
Hello there. We are pleased to present to you today Jeff Lindsay, which is a creator of Flynn and Doku tools, which are leveraging of on Docker, and which is just there today with us prior to the next meeting, .scale, on which we are going to present something today, tomorrow. Sorry. So here we go. Thank you.
Thanks. All right, so we're set up. Yep. So, show of hands, how many of you are developers? How many of you are operators? You can be both. Okay. So, building the ideal developer platform. This talk is about a project I've been working on called Flynn, and turns out the ideal platform isn't really a platform at all. Kind of get to that. So real quick, from Austin, Texas. It's a lot nicer there than you would imagine, as far as it's very green and pretty. I only just moved there, so I'm not quite at the 1 year mark, but I'm getting there. Austin is a place, they say, keep Austin weird. So it is weird. You've got this sort of liberal, young city with, you know, kind of modern progressive, and then you have Texas all around it. I used to live in this city. What city is this? Yes. Well, you knew. I was trying to throw you off because this isn't the main. That's not the Golden Gate, and that's not the main skyline. But I used to live there, but not in that building, but in a tiny building behind it. So I've worked at a lot of companies, or worked with a lot of companies. Right now, I'm working with DigitalOcean, Twilio a while back. NASA sounds so fancy, but it was really when they were working on Proto OpenStack. .cloud, I worked with them briefly at the early stages of Docker, and some others that aren't relevant, but I'm mostly known for my open source work. Hacker Dojo is a space hackerspace/community center, something or other in Mountain View, California that I helped start. It's a fun place. Anyway. So I'm not sure how to describe Flynn, and but I'll try. So we market it as an open source platform as a service, and that's kind of a right answer. It's not the best answer. A toolkit for building modern systems, sometimes I say that. I like this one because it sounds pretentious. Postmodern meta platform. But I'm playing with this idea of calling it a meta stack. I don't know, we'll see. Has anybody read this book? It's from 2006. This is like your fundamentals of building websites, building and operating websites. It was written by a guy named Cal Henderson. He basically wrote Flickr, and Flickr was actually this book actually was sort of the precursor to the whole DevOps movement. It goes into a lot of things like this book. It's not just about architecture, but also about your delivery pipeline and everything. It's a very kind of holistic, systemic view of building scalable websites with cheap hardware and open source software. After this book came out, it seemed like everybody started doing things better, and probably by now it's just part of our culture. We already, pretty easily everybody knows how to build scalable websites with best practices. But I wanted to help frame this. The reason why I bring this up is because it's not very helpful if you don't know the book, but the way I think of Flynn is almost more a worldview. Like, it is a project. It's a bunch of projects, but it's almost a worldview or a way of thinking that would be, if you were to write this book in 3 years from now, that's how I think of what Flynn is. So because that book's from 2006, so it's a little dated. So I want to give you an example of kind of two existing ways of thinking: the traditional, which is what that book talks about, and then a more recent one, which is using platform services and software as a service, which is part of the inspiration for Flynn, but it's sort of a limited way to go about. So I'm going to show you. We're going to pretend we're building a photo sharing app like Flickr, and to try and contrast host-based. I call it host-based thinking or host-based infrastructure versus the platform service stuff. Because there's really this divide between these two worlds. Almost nobody does stuff like using Heroku and App Engine. Almost nobody. And there's reasons for that. And this is the way most people do things, right? They set up servers and they put Chef on it and whatever the latest thing is there. So starting with the traditional way, let's say we have an app, that PHP app running on a laptop. We'll put it online, so we'll put it on EC2. So we're going to have to split it up and run a couple of instances of everything, and so we set up load balancers, HA proxy. Then we set up an actual master-slave MySQL cluster, and we start getting bottlenecked when we do image processing, because we're a photo sharing app. Our Apache processes and our app servers get blocked by this, what should be an asynchronous background task. So we'll set up an asynchronous job cluster. We'll use Gearman. Anybody know Gearman? Some old school tech here. So those will do the image work and then put the images in, let's say, the database, but that's silly, so let's set up a distributed file cluster service, MogulFS. Apparently we like Danga technologies. So still too many database reads. We'll set up some caching with Memcache, scale a little bit, set up a metadata cluster. A newer thing, we'll use React. But then the app now is this monolithic thing, so we'll split that up into maybe an auth app and an API app and a front end and a static corp site or something. And we could keep going, and you could kind of keep refactoring. This is how a lot of sites evolve. This is pretty close to a photo sharing site that I know, not Flickr. But what's missing here? If you were to continue to sort of map out what it's like to build and operate one of these systems, what's missing? What's that? Well, I'm looking for more support build system. You know, you're managing all these servers. Maybe you're using Chef. You got to run Chef server. Maybe you're using GitHub Enterprise. Whatever your source control is, it's really part of this process. And you usually build internal apps. You know, maybe managing customers and stuff like this. There's usually a lot more to your app than your app, and then there's all the tooling that you use to manage this huge thing. There's usually more than this, but this is all part of your system. Most people don't think about it like that, and most app developers only think about these guys. And when they split these up, then they think they have service-oriented architecture. But they had service-oriented architecture to begin with. But only operators think about that. Of course, and DevOps is, you know, kind of trying to get on the same page, and everybody thinking about it the same way. But anyway, this is a complicated distributed system you're setting up. And I guess one message here is, like it or not, as a web developer, you're going to be building a distributed system. So you kind of need to know that stuff. And this operating environment includes so much more than just your app and your backing services, but all the support services. And for real DevOps to work, both ops and engineering should be working in the same paradigm. They're not. Like, developers work in their source code, working in whatever language stack they're using. Operators use whatever they're doing, usually Chef these days. Apparently DevOps means Chef, but it doesn't. So now let's go and look at the platform as a service way of doing things. In this case, using Heroku. How many of you used Heroku? You like it? You like using it? I mean, it has its limitations, but it's a pretty good experience. And on Heroku, you basically it runs the app, and then you use third-party backing services for everything else. So they have hosted Postgres database. You can use CloudFront and S3 for your caching and file server stuff. You can use a hosted Memcache cloud service. Iron Worker to run some async tasks that'll then run them on Heroku. DynamoDB we could use for our metadata. And then, of course, all our support systems. We can use GitHub.com and maybe Circle CI and some other stuff. And so then we have something roughly like what we built before in the traditional way. And there's some advantages, a fair amount of advantages. This is a pretty self-serve system. Most developers could have thrown all that together. It's process-oriented compute. Heroku, you're not managing servers, you're managing dynos, which are basically just processes. And you have easy deployment and management, which is where you get the phrase no ops. But what's the bad? Why don't people do this? Anybody? Yeah. Yeah, I mean that's a plus, but why? So why don't more people do that? Yeah. Yep. Yeah. So you've limited functionality. You can't customize anything that they don't let you customize. So not as much flexibility, not as much control. You can't enforce, you know, certain SLAs because you're dependent on all these third parties. And what I'm surprised most people didn't bring up is it's expensive. So at Twilio, this is my fake diagram of the Twilio architecture. Twilio is much more complicated. There's 200 different services that run Twilio. It's highly service-oriented architecture. But it could never be built on Heroku for a number of reasons. The limitations, the SLAs that Twilio had, custom configurations and data stores and all that stuff. But we wanted, it'd be really nice. What we had, we ran on EC2, but it was the system that we set up to manage our hosts, and this was before a lot of the great tooling, like even RightScale and some of that early stuff even existed. So Twilio has homegrown management stuff, and it's just terrible. The delivery pipeline is horrible. But we wanted something like a Heroku, and then managing that system is very complicated. We wanted a Heroku, but we wouldn't be able to do it. So then we started thinking, if we could have anything, what would it look like? Kind of looks like Heroku. Microservices. No, I won't talk about microservices. So coming back to this divide of host-based and platform-based infrastructure, I guess what we're trying to do with Flynn is try and bridge this divide with components so that you can build your own PaaS-like platform that's not necessarily a PaaS. It's not going to be exactly like Heroku. It can be really whatever you want, what you like about Heroku, and still have a lot of the flexibility and control of hosts, but not work with hosts. It's kind of needed, because if you were to start with Heroku, it's a lot of work to then go, when you run into those limitations, and then have to rebuild everything the traditional way, because it's a completely different way of thinking and building your system. Okay, so what is Flynn, really? Well, I can't even get it down to one description, but one description is a distribution of components providing a starting point for an internal platform. Notice I said internal platform. This is not like a Cloud Foundry. It's not like an OpenStack where its main users are people that are going to resell it. This is a platform made for you to use and control and customize for your particular system. But I more think of it as just a collection of independent projects with a common worldview that make up a toolkit for building distributed systems. So it's kind of a platform, but kind of not. It's a meta platform or a toolkit for platforms. I don't know. So I'm going to talk a little bit. There are so many concepts and ideas in here that I really have to stay at a conceptual level. I would show you demos and stuff, but it's not that exciting right now as an open source project in development. There is a developer release that you can try and play with, but I think what's more important, the more valuable thing about Flynn is the worldview and thinking about things differently. So that's what my talk mostly focuses on. And our process is kind of rooted in, my design process is rooted in idealized design, which is a simple concept. It's, always be thinking about what you want regardless of what you have. So you have a conceptual model of, if you could start over, what would it look like? And it requires a certain amount of design thinking to have that be useful, because the goal is to try, in your ideal system, it's probably going to be simpler, it's going to have less moving parts, it's going to satisfy more requirements without being more complicated. But that's not how software usually evolves when you're just, people want a new feature, so you add the new feature, or there's a bug, so you fix the bug. When you could actually, if you step back and rethink the design, you can actually dissolve those issues with a simpler system. And Rob Pike, so we use Go a lot. Mostly all of Flynn is written in Go. And Rob Pike, he's kind of an old school Unix guy, and I love this quote that he has. And so the idea is, by having at least an idea of what you want, if you could have anything, if you could start over, then you can continuously move what you have towards that. So when you're refactoring it and you're iterating, you're actually iterating towards something that you know you want, as opposed to just iterating. Flynn is also at the intersection of three worlds. There are sort of three different perspectives of how the world should be. In the web world, and that's mostly talking about web APIs. Everything should have a web API, probably be RESTful, probably be JSON, stuff like that. distributed systems, you have a lot of academic knowledge, things like lock servers and leader election, and a lot of the hard problems that most web application developers aren't as familiar with. And then you have Unix, which itself has its own sort of philosophy and way of thinking about things, which we adapt a lot of that because a lot of that philosophy is pretty generally applicable, right? We actually have our top 6 ESR Unix rules. Are you familiar with the either Unix rules or the Unix philosophy? So these are our 6, and I won't get into the specifics, but just to give you an idea of some of the ideas that we try and borrow. But maybe you could boil it all down to 2 things. We want it to be hackable. That means that it's easy to get into and understand. So it's not just here's a solution, read the docs, use it. It's actually something that's pretty simple that if you wanted to go in and see how it works, it's very readable, discoverable, learnable, and it's flexible. It's not really designed to be a solution that solves all your problems. It's something that has a lot of flexibility, and you can solve your particular problem in your particular way. One audience, and this kind of comes back to the idea of DevOps and having a common paradigm. But the idea is that the user, we don't really make a distinction between the user or the developer or the operator of Flynn. They really should just all be the same person and think about things the same way and have a holistic idea of the system. And that also forces us to make things very simple and well documented. Okay, architectural principles, a little bit more specific, less meta, but still abstract. Abstract the host. We don't want to manage hosts. Probably realized that by now. We want to manage process. All of my life, I feel like, I've just wanted to be able to run processes. I don't want to have to manage Unix servers. So that's, the host should just be a vessel for running, an appliance for running processes. I shouldn't have to think about managing its configuration, its, inetc and all that stuff. It should just do what it's supposed to do. And this is what I was talking about. It's not really a platform in the classical sense that you just build on top of it. It's really something you build with. You could think of it as a toolkit. That's where the real value in Flynn is. The idea of these components that let you build things in this way. Traditionally, platform services have this concept of your app, which is separate from backing services. But really, at the end of the day, they're just processes. In this case, running containers. And so in Flynn, that's the main building block. Everything is just processes. Containerized processes all the way down. Kind of like that, I guess. I just like leaving this up to see how long people can stand looking at it. One time somebody yelled out, "Turn it off!" I don't know why people can't handle that. Okay, so another principle, everything has an API. I mean, on the web, it's great. You're like, man, I wish there was an API for this. Twilio is an API for doing SMS and telecom stuff. And so that's a world I like. I like being able to say, oh, there's an API for that, and that you can programmatically control things, as opposed to managing configuration files. It's such a weird, old school way of doing things. So everything has an API, has hooks, is scriptable. In a way, it's like software as a service all the way down. It's like all your components should be little software as a service components that you can run and treat. They have an API and everything. So this is kind of a generalization of, things like fault tolerance and automatic failover and real-time scaling and fast deploys. You need this system needs to live on the cloud. It needs to deal with all these things. So it needs primitives that support real-time adaptability. I mean, in the old school traditional host-based infrastructure is rooted in that concept of static machines, where things don't change that much. That's not how things are anymore, increasingly. So more and more of things like static configuration is turning into runtime configuration. You can change with APIs and stuff like that. And MetaStack, like I said, it's stack agnostic. We're not solving distributed systems by saying, here's Erlang, do everything in Erlang, or, Akka or whatever. It's service-oriented architecture, meta platform, so you can build things in whatever you want, as long as it runs as a Linux process. And then this is the last one, yeah. And then the last principle is it's the way we think about things is edge-oriented. I don't have a good name for this. It's not exactly decentralized. It's just avoiding centralizing where possible. Because a lot of people do this in communications. You'll have central generalized message queues or ESBs or something like this. Those are bad. So you can do that in Flynn for your system, but Flynn is designed to avoid that, and hopefully that encourages you to build your system in a way that follows that principle. And same with state and data. The state that lives at the edge should be accessed from the edge, as opposed to saying, you have a process on a host. Is it running or not? And so sometimes you'll have a central system that has in its database record, something about a process and whether it's running or not. And so that's what you would check. And then you have to somehow keep those in sync. Well, why not just check to see if the process is running or not? So anyway, App Engine, obviously huge inspiration, being one of the first platform services. Very full service. Comes with all kinds of built-in backing services. It's a very batteries included approach. It's a very walled garden. They sort of live in their own world. None of these are really useful outside of App Engine, and you're sort of locked in when you start using them. Heroku's a little better because they focus on managing processes. Basically, really, the core of Heroku is managing dynos and having a routing layer, and that's like all their technology is. But and then they defer everything else to third parties. And then Mesos, which is, I mean, Mesos has been around for a while, and how many of you are familiar with Mesos? Because this is very much the direction, the way of thinking that Flynn is sort of the foundation of Flynn. So Mesos is a project that came out of UC Berkeley, adopted by Twitter, made by ex-Google employees that missed a project that Google had, a system called Borg, or that's what they called it. And so people called that their secret weapon. So Mesos is an open source version of that. It's a cluster management framework. It's kind of hard to describe also, but in general, it's basically how you would map compute jobs to resources. So Google's working on a replacement to Borg called Omega. It's a little bit more what Flynn's scheduling stuff is based on their paper, since it's not open source. But it's basically a distributed computation scheduling framework. It's a system to match computation work with resources. And I know that's very computation work. It means a process. You're going to run a process somewhere on a thing that has storage and memory and CPU. How do you get it there? And in that way, you can abstract the host. You just have a bunch of resources, pool of servers, and instead of saying, I'm going to run this on this server, you say, I want to run this process, and I need so-and-so. Go figure it out. It's kind of like what Heroku does. Heroku is a very sort of dumb version of this. But this is the foundation of Flynn, so we built it as sort of a scheduler that helps us abstract the host. So now, still architecture. So we split Flynn into two kind of layers. I don't really like this naming scheme, layer 0. It's just the first thing that came out of our mouths, I guess. Layer 0 is sort of like the kernel, and then layer 1, there's no more layers. Layer 1 is like user space. Probably better. If it was Flynn kernel and Flynn user space, it would probably be a better metaphor. But layer 0 is a container compute grid, something like a Mesos, distributed coordination. So a lot of the heavy lifting doing, it's kind of some of the hard work in building distributed systems is in distributed coordination, so we provide primitives for that since we need that ourselves. Service discovery is a huge kind of core primitive of this entire system, and having a means, at least for our services, that we encourage you to use for your services, but inter-service communication. So I think that's a pretty, people are like, oh, that's a solved problem. Use HTTP, which normally I would agree with, or use any arbitrary RPC technology, but I disagree. We came up with something better. So in this layer 0, we have a couple of technologies you've probably heard of. To me, Docker, I wanted to build Flynn before Docker existed. And I collaborated with .cloud in the early stages of Docker, really to make sure that I could build something like Flynn. And actually, the first talk that I gave about Docker is at a conference that I'm actually going to after this trip to go there again, but a conference called GlueCon, and I gave a talk called Building a Platform Service Using Docker, and Solomon came along, and back then he was really terrible at talking about what Docker is. We kind of all were, and we knew it was big. We would say containerization is the new virtualization a lot. But I designed Docker, my influence in Docker was trying to make sure that it can be used to build these kinds of systems. And actually at that conference, at that talk, the demo that I made for that talk is what became Doku, which is an open source project that is a single host version of Heroku based on Docker and like 100 lines of bash. So most of the heavy lifting is done by Docker. Surprise, surprise. Funny thing about Docker, you've probably all heard this before. It's originally about LXC containers, but they're really much closer to Heroku dynos, which some people talk about, call them application containers, to differentiate between old school Linux containers and what Docker is really about. And there's there's confusion because of that. I tweeted once about looking for photos to talk about Docker, and it was like, I always, looking for a photo that has shipping containers, I always get caught up looking at shipping container architecture. And I tweeted that, and somebody said that shipping containers is a useless metaphor for LXC containers. What do shipping containers have to do with LXC containers? But that's true, but Docker is literally trying to solve the same, Docker containers are trying to solve the same problem that they are. LXC containers not so much, but Docker containers are. So, create a standard box, put anything in it, ship it anyway, run it the same way. You guys all know that already. And then here's some container architecture. There's actually a lot cooler examples, and I always spend too long looking at those. So Docker is our application container management system at the heart that we run on all the nodes. If something else, and there are actually, believe it or not, there are other people working on Docker alternatives, but ideally based on the Docker model. So it's sort of a Docker compatible application container system. So if there ever are alternatives, maybe lightweight alternatives, they would at least be Docker compatible, because Docker solved this high-level model of this high-level container. So another component next to Docker is right now we use etcd right now, but I'm also exploring console, which recently came out. Both of them are raft-based configuration coordination. These is kind of one of the harder problems in distributed systems is coordination, locks, leader election. I mean, shared state is sort of an anti-pattern in these, building scalable systems, shared nothing architectures, but you need to bootstrap that a little with a little bit of shared state and coordination. So that's what these guys are for. We also use them for service discovery, which is kind of getting a little bit more popular in terms of service discovery. We need that. If you have like a central message queue or an ESB or something like that, you don't really, because it kind of solves that problem. But when you want to do brokerless messaging, service discovery is very useful. So we have a service discovery system built on etcd and console. And technically they're both already solutions for service discovery, but we had particular requirements, so we made a project that wraps etcd. I'm trying, though, in the spirit of trying to simplify things, the version that I'm working on with console is trying to eliminate this component. And then I mentioned this, our inter-process communication. It's a project called Duplex that I would show you if I have time, but it's a cross-environment. I mean, how many RPC protocols, libraries, whatever, actually are something you can use from any language? 0MQ is pretty close, but it's not exactly RPC. And a lot of this was inspired by .cloud's work with 0RPC. But Duplex is cross-environment serialization neutral, so you can use JSON or protocol buffers or Captain Proto. But it also supports streaming both ways. So you can stream back results, but also stream out arguments or input. And the cool thing is that I made sure that it feels very like 0MQ, but it also supports callbacks and kind of for building plug-in architectures, so that I can't give an example without actually showing you an example. I assure you it's very cool. And then all this is kind of wrapped up in this project called FlynnHost, which is just a single thing that you run on all your hosts. All you need is Docker, and you can turn a bunch of hosts, run this command. Doesn't matter what else on the system, it's all running. That's one of the other principles of Flynn, is everything runs inside containers, even Flynn itself. So all these other systems that set stuff up in the host and is dependent on whatever your host operating system is, Flynn's not like that. It all runs in containers, so all you have to do is do a Docker run to bootstrap the system. And then you have a really simple, kind of a Docker-powered Mesos. We have now this grid with a host service running on all of them. And at this point, you still need to write scheduler logic, something to figure out where to put stuff and how you end up figuring that out. But this is a we give you the tools to make that really easy, especially since everybody's scheduling logic is going to be slightly different depending on what kind of SLAs or whatever your policies are. Everybody's systems are different. And I'm actually trying to wrap that all up into, just because there's so many projects, and I'm trying to consolidate them into single, slightly more monolithic projects that wrap all those up into a single project. And so if there was a project to encapsulate the Flynn layer 0 stuff, this would be that. But it doesn't exist yet. I'm slowly working on it. It's not necessary for the sort of like traditional Flynn stack where you're building a platform as a service, but this will be very cool. It'll be like a very good alternative to Mesos that is very hacker friendly, very simple, that gives you everything that I was just talking about in a very user friendly way. Right now we don't have that. Right now we just go directly into layer 1 stuff or user space stuff in Flynn. And so at this point everything is in containers. So everything you need to build Heroku on top of this is in this layer of stuff. We've got Heroku-like control plane, like an API server, and modeling apps and stuff. Configurable delivery pipeline. So if you want, the idea is you can create other delivery pipelines, not just git push or whatever. One of the secret sauce of Heroku is their routing system. Of course, it's somewhat limited, but so we have a more general dynamic TCP routing that, of course, could be replaced by anything else, logging infrastructure, etc. So just to kind of give you an example, and we have most of these written since we have a working version. The host service is Flynn host. We have a Git front end called Git receive that will just, it's an SSH server made for accepting Git pushes. Controller API, this is where a lot of our scheduling is. We have a router project called Stroger that can be replaced with anything else. I'll show you that. And then these are really the Heroku specific things. This builds a Heroku slug using the Heroku build packs, and then Slug Runner just runs those slugs. So assuming you have this grid, you can start bootstrapping a Heroku system by deploying. Flynn sort of takes care of all this for you, but just so you can think through what's going on. Flynn bootstraps Git receive, so there's a Git front end, and it's going to say, oh, well, that needs to run on a public port 22, so our scheduling system can figure out which machine has a public IP with an unused port 22. Okay, and a router, same thing. We need port 80 and 443, and it figured out, oh, maybe this is the only machine with a public IP, so it puts it there. We need to deploy our controller, and what happens next? Okay, so let's say at this point we have something we use. If we push something to Git receive, we do Git push a little Heroku app that then uses service discovery based on the infrastructure that's already there to figure out where the controller is, tells the controller says, I need to build this, so it deploys a slug builder process on this grid, then builds the project, takes that output, puts it somewhere, and then it will deploy a slug runner that's pointing to that slug, and it will run that. And then this is set up so now the router is, it knows about the app. The controller tells the router to start routing stuff on that domain to that app. You can deploy 2 of them. It'll balance both of them automatically because this router is based on service discovery. So if both of these containers register a service with the same name, it'll balance between them in real time just as it comes online. Yeah, that's kind of simple, right? Once you have these primitives, that's the idea. So the idea is that I want Flynn to be able to build a system like this, not just apps that you can deploy on Heroku, but full distributed systems, customized exactly how you want. You would build that on top of that grid, but it's going to be more resource efficient. Twilio runs 200 services, and they have to run twice as many for redundancy. So they're running 400 servers on EC2 minimum just to run. If you could co-locate those on the same hosts using containerized, this grid compute stuff, huge benefit to resource efficiency. It's going to be more real time, a little bit more automated. You can just kind of throw things online. They'll automatic. You don't have to change a chef config or whatever it is that you're going to do, or whatever your old school configuration management way of thinking. And it's all, it's not, there's no chef involved. It's all about components with APIs that are written, and you can actually deploy any of those components using the same mechanism that the application developers use. So it kind of puts everybody on the same paradigm using the same tool chain, and that's really important for actual DevOps. But you still have a lot of the benefits of platform systems. And so the goal is to be able to rebuild a system like Twilio on Flynn, not just simple web apps, but while retaining certain properties of platform services in terms of automation, abstraction, developer experience, etc. And bridge the gap between hosts and platform services. But ultimately, if you really were following what was going on, kind of obsolete both of them. Like, passes are dumb. Like, I love passes, but only in that it gave me a new way to think about stuff and develop technologies like Docker. But most past businesses are going to fail. Host-based infrastructure thinking is too old school. Somewhere in the middle using components like Flynn, that's the future I want to live in. So, distributed systems are full of complexities. Hopefully Flynn can address complexity without complication, to pull inspiration from Arch Linux, which is a distribution of Linux made for embedded systems. Has to deal with this as well. Linux itself is full of complexities, and the way Arch approaches this, and I love that they have this as a very explicit thing called the Arch way. But the way they deal with that is keep it well organized and transparent. And sometimes trying to hide those complexities just makes things more complicated. So again, coming back to these core tenets, I think if we... So Doku actually taught people, because it was very hackable, very discoverable, said it's only 100 lines of code. So everybody read those 100 lines of code, bash. And very quickly people started seeing how you could build a system like Heroku, granted on a single host, but it's interesting that it taught people. And so my hope is that Flynn, these components, this worldview, all this stuff can kind of teach people about distributed systems, especially application developers. And strangely, there's no project that represents sort of a systemic view of building real-world systems. Like there's databases, and there's certain projects that kind of teach you about certain, say relational databases or NoSQL databases, or projects that teach you about these concepts. But there's no project that teaches you about the entire system. Flynn is maybe that. So that's it. If you want to learn more, you can go to flynn.io. There's also an IRC channel on Freenode. So if you want to go to that channel on Flynn, called Flynn, and then I'm Program on the internet. So that's all. Questions? You want me to turn it off? See, there's always someone. Okay. Yeah. Dot scale or what? Or dot or I don't think I'm familiar with those. Oh, are you talking about what were they again? I don't know why I've not heard of those, but I mean, out of the box, we're kind of Heroku-ish compatible. But the idea is that if you know how those systems work, they're not all that different. A lot of them is just like taking some configuration file and then somehow making that execute somehow. So like Heroku has proc files. .cloud had their version of proc files. And whatever kind of configuration or convention the system uses, that's just a matter of building a custom delivery pipeline or something like that. Because functionally, it probably supports the same ideas, and if it doesn't, you can just make it do that. So, I mean, we're not going out of our way to support lots of different models, but and like I said, this isn't about building a platform service. It's building a platform. Building a PaaS-like system. So the idea is that if you're building a system for your company, your startup, whatever, you don't necessarily want it to be exactly like Heroku or exactly like .cloud. You're going to want it to have whatever requirements for the problems that you have in your organization. So, that answer the question? Yeah. Yeah. No. Yeah. So that's, good point. Data state is a very special problem. So far, pretty much everything here, besides the shared state stuff, is stateless. or has like ephemeral state. And so they don't really need databases, or the little state that they do, they can either keep locally or in memory or in etcd. When you're talking about actual data like user data, metadata, whatever your application has, you're going to still deploy something like a React, but you deploy React on Flynn. But then it's going to be treated a special way. So we're very explicit in our resource scheduling that certain things that you deploy are going to be stateful and some are going to be stateless. And so one kind of design pattern is to just be very conscious of that. Try and make things that can be stateless, and consolidate all your state in stateful things. That, for example, you could run, if you're running on EC2, you could then run your own hardware, link them together in a single Flynn cluster, then, because I/O performance on EC2 is not great for a lot of databases. So you just run your own hardware and kind of put it will just schedule all your stateful stuff on your hardware with the better disk resources. So it doesn't, etcd is not enough. In fact, you should almost not use etcd as much as possible. Yeah. Yeah. Surf, gossip protocols are by nature not consistent, so that you don't have a single global. That part of the value of data stores like etcd or Chubby or any of those is that they do have a consistent, they have that consistency guarantee, or at some sort of consistency guarantee, because the whole point is that you're all agreeing. That's the coordination part. So gossip protocols aren't good for coordination, and the authors of Surf knew that. That's why they wrote Consul. So Consul was a project that I mentioned. It's newer, so you might not have heard of it, but it's actually very similar to etcd. It's also written in Go. It's written by the authors of Surf and Vagrant and all those other stuff. And it's actually built on top of Surf. So they use Surf to set up to coordinate between their clusters, and then they provide a Raft consensus algorithm on top of that. So it provides you the same primitives and semantics as etcd, and they just happen to use Surf for other stuff. But for me, Surf is not very useful for any of the problems that I would solve here. Maybe in some edge cases, but usually you need a consistent store, distributed consistent store. Yeah. So is your multi-tenancy scenario one where you actually have different users that shouldn't be able to talk to each other? So I think we made an assumption, and at some point we might have to address this, but we made an assumption that there isn't multi-tenancy baked in. Almost any host can access all the data and all the Flynn host etcd stuff like that. The place where we did think about it was when designing duplex, which is our main communication protocol, but kind of have to think about it for stuff that doesn't speak duplex. But having TLS key-based authentication, so just putting everything through a TLS pipe, and then having client authentication with keys all over the place, and then have some automation. Actually, it's kind of that pipe dream of key-based security, but automate it all, and that way you can start controlling what actually is able to talk to different things. And so that's as far as we've gone thinking about that sort of thing. But as far as other types of, I mean that's the networking multi-tenancy, being able to connect to other things. If we take care of that, then you shouldn't be able to connect to something that you're not allowed to connect to. But we haven't done that yet. Exciting stuff. It's yeah, it might be a little bit more complicated now. Go to flynn.io and there should be instructions. I'm not completely up to date on it because I sort of fell out of the sort of development on the mainline like full thing. I've been working on a lot of the newer components, so things might have changed. But the idea is, yeah, you can just run one Docker command on the host that you're going to run, that you're going to include in your grid. So you need to be able to log into your server first, and then from that you can. Actually, I don't know how it works now, so I shouldn't say. There is a Flynn command line tool. It's sort of like the Heroku command line tool that gives you access to controlling a lot of stuff from because it's all just wrapping an HTTP API. So a lot of the higher level like platform service Heroku-like functionality exposes an HTTP API. But because all the services have their own, all the components have their own APIs, and so if you wanted to, and if you had direct access to that network, you could connect to them directly and start controlling them via the sort of internal RPC stuff. But I imagine that's an advanced use case. You wouldn't normally do that. Everything that you need should be in the command line tool, which is a Go binary, so it should be easy to deploy and run everywhere without dependencies. Oh yeah. Yep. Yep. Yeah. And we talked about dynamic binaries where the cluster then gives you a binary as well as an easy install mechanism for your users. Maybe we don't need to go that far, but yeah, the idea is making it simple, and that should be all you need: the binary and Docker run. Though, I mean, for now, and the way I think, because again, I'm a little less involved in the full stack, like making a platform service type of thing. I'm more involved in thinking about building an internal platform for operators and developers. So there's sort of an assumption, or my assumption, is that you kind of, know the entire system. So as you're setting it up and learning it, you're sort of figuring out what you can do with it. Well, no, hopefully it's sort of a spiral kind of thing where it's like, you don't have to know anything, you can kind of get stuff done with it, and then when you want to tweak it, you can kind of go and look and see how it works, and you're like, oh, I can tweak that, and then that just continues on, and you can kind of learn how the system works by using it and wanting to do things. There's actually something in Doku, is almost intentional. It doesn't solve a lot of problems, and so it almost forces you to go and read the source. It's 100 lines of bash, so it's not that big of a deal. But even though people are like, oh, you shouldn't have to do that, but once they do, they have a way better understanding of how the system works, and they feel more comfortable and confident in it because they know how it works and they know what they can do with it. And so I don't necessarily want to force people down that path with Flynn, but I want that to be possible so that people, kind of, it's the whole idea, making it hackable and sort of discoverable, because you should know how it works. There's never going to be a magic bullet. Like almost every database services, whatever, you have to know how they work in order to use them properly, at scale. So. Yeah. Yep. The idea is that you should be able to, it's kind of a, it should, you come for the Heroku-like experience and you stay for the, complex systems support. So yeah, your initial experience should be like Heroku. Hackable Heroku. Yeah. But capable of so much more. And there's a lot of other stuff too, but we'll see as things unfold. Anything else? Deus? Yeah. Yeah. It's a little bit. There's also Suru, and I'm trying to think of some others. Obviously Cloud Foundry, but I kind of don't. I kind of ignore Cloud Foundry. Cloud Foundry is kind of old school. Cloud Foundry is sort of like the open source equivalent of App Engine in that it was the first one to do it, and so it did it in a sort of limited concept of the world, but now they're stuck in that concept, and so everything is just kind of a patch or an iteration on that. They're getting better though, but they're still, because they're enterprise software, they have a lot of resources, but going in all kinds of different directions. Deis is more interesting, but it's interesting because I collaborate with them. So they're already using components that I've written for Flynn. That's the idea, is you can, Flynn out of the box is a distribution, sort of like a Linux distribution. And there can be many different Linux distributions made up of different components. And so in the grander scheme, Flynn is like Linux, right? It's a way of thinking, and you can have different distributions that compete on how they package things up and how they make the experience. So far, Deis is mostly their own components, but slowly they're using Flynn components, and I talk with them on a regular basis as well. Also, the CoreOS guys that write etcd. It's great. That's what I would run Flynn on. I mean, it is it's the only operating system I've seen that's like, hey, you're going to be running everything in containers, so let's design the operating system for that. That's perfect for Flynn. And they kind of expand on that by kind of borrowing the Google model, just to automatically update, which not a lot of operating systems do that. Yeah. Actually, I don't know if they have channels, but they should. Oh, good. Yeah, that makes sense, because they're basically copying Google Chrome. I know that they want to do platform stuff. That's why they sort of hired me. But right now, that's sort of more of a sponsorship because of the fact that they're still sort of getting their infrastructure as a service, VM-based infrastructure, solid. And so that's most of their engineering resources is spent on that. So they're not at the right place to be thinking about platform stuff, but that's on their roadmap. What it looks like, I mean, I work there and I don't even know. So it could be hosted Flynn, maybe not. Could be something else. Could be, a customized version. It could be just powered by Flynn, and it's like something else entirely. Yeah. Well, that's probably going to come sooner than anything else. But that's probably from me as opposed to DigitalOcean officially. They don't support multiple boot partitions in their current version, but their new version that has been deployed in some of the other data centers does. So as they update the older data centers, they will support CoreOS. So that's coming. But yeah, I try and stay in touch with all the people in this space that think in this sort of way, just to sort of, like the Deis guys, I went to visit them and they were talking about, it's great because they're actually selling this to customers. So they're grounded in reality, what do customers want. So I get a lot of my knowledge, and validation from them. And but also architecturally, like what are the problems they're running into. And recently they switched to using Fleet, which is a CoreOS scheduler-ish thing. It's a little bit, it's similar to what our Layer 0 stuff does, but it's a little bit more limited. And they would be using Flynn's if it was a little bit more baked. They want to. But so for now they're using CoreOS's Fleet, and one of the problems they have to solve is logging, so log aggregation. So wherever you're running, you have to get those logs out and send them somewhere. their solution is to run a unit, a systemd unit job on Fleet for every container that you run that will attach to the container and then pipe it into the logger command. And so it's just like a bash script. It works, but I mean, it's not ideal. I recently released, after seeing that, I was like, oh, let me solve that for you. So I built a project called Logspout, which is 100% Docker containerable thing that attaches to all your other Docker containers and lets you route logs wherever you want via an HTTP API or simple command line argument. So you just run this, Docker run it, and it will route all your logs somewhere and let you stream them over curl and all kinds of other cool stuff. So that's like a standalone component that's very useful for Docker in general that will be baked into Flynn as a component of Flynn, based on that worldview of making components that have APIs that are useful by themselves and all that stuff. It's not related to... So there's the other guys that work on Flynn that kind of helped make it happen and did the sponsorship stuff last year. We argued about the name for a long time. They name things funny. I think they name things funny. Cupcake, things like that. Tent. So we talked about the name, and I think Flynn was the only one that we all agreed on. It's sort of like, okay. But it's a reference to Tron. So then you can see how we kind of joke about layer 0 being the grid. So yeah. Yeah, the guys that built Tent protocol, they I mean, they're this community, but it's basically these two guys, and I was already familiar with them because they used a lot of stuff like webhooks in their API, and they wanted to build some sort of open source platform as a service because they knew, again, a lot of people, it turns out, want an open source platform as a service. Now there's open source platform as a service, but of course I'm trying to say you don't really want open source platform as a service, you want a toolkit for building it. But and they kind of agreed. So in terms of, they shared the same architectural principles, basically everything that I described here. So they said, we want to hire you to collaborate on this, and finally we did a sponsorship model so that they could pay me to work on it. And yeah, to be clear, I really only work on this stuff if I'm paid to work on it, which sounds terrible, but that's the only way I can get it done. But yeah, so we did a sponsorship type of model, almost like it was a self-starter, like a Kickstarter-esque sponsorship thing, and they paid for last year, up until the end of last year. And then this year, there was a lull where I was not able to work on it, and then I ran into DigitalOcean. Now they're sponsoring me again. So, but yeah, they're the other half, the Tent guys, Cupcake or Pollock Software. Hang out. Yeah. Cool. Thank you.